Today is our good evening, everyone. So today is our topic, unit 10, the last unit, for our biostatistic paper. All right. So today I'm going to talk about. Let me see. I'll show you the. Okay. Hope all of you can see the screen. Just have a look. I have covered everything on the lecture topic. All right. Understanding basic of dental research. I did talk about that. All the slides are given to you. Yeah. If you don't have any slides on that, please let me know. Right. Okay. And then I talked about literature review, research design, sampling technique, collect and record data, then introduction to biostatistics covered. Probability and distribution I already added because we can only have 10 lectures, so I already covered with the probability and distribution under hypothesis testing. Under hypothesis testing, after that I did introduction to SPSS. How do you key in your data in SPSS, and what is the variable list and what is data view. After that, I went into test of significance. All these comes under 10, 11, 12, 13. As I told you that all this I categorize into two lecture lah. Yeah, I put it in two lecture because most of you will not be using very high level data analysis like ANOVA, MANOVA and all that. Yeah, the highest level that you'll be using is t-test. So I covered on t-test, test of significance. I also talked about what is p-value, all that on your lecture notes, in the lecture slide and in my video. And then I also talk about Pearson correlation analysis. So today I'm going to talk about non-parametric tests and developing skills in oral health education. Yeah. So I'm going to combine these two, non-parametric tests and developing skill in oral education. I'm going to combine both of it. Okay, let me start with the non-parametric test. Non-parametric test. What is the learning outcome? To distinguish the parametric and non-parametric tests, to identify the reason to use non-parametric in certain research data, and to analyze each of the type of non-parametric tests. Okay. So why are we doing non-parametric tests? Why are we doing non-parametric tests? So we will see what is a parameter, what is a assumption in parametric test, and what is the assumption in non-parametric test. All right. We are talking about non-parametric test, and the learning outcome I follow according to the outcome given in your outcome, given in your syllabus. All right. So variable, this is what we are going to talk about. Variable. Just few minutes, All right. Variables, we have dependent and independent variable, and the measurement. I'm sure you're clear about this independent and independent variable. And measurements, we can take measurements, can be either in nominal, nominal scale, as example, gender, ethnic, eye color of the eyes, blood group, they all come under nominal. Ordinal, like school performance, social class, economic class, SES. Then interval scale is like example Celsius or Fahrenheit scale, weight. Ratio, it can be also in the temperature scale, pulse rate, respiratory rate, and so on. So these are the measurements that we do take. Okay, next one. Parameter, what is the parameter? Is any what you are going to measure, yeah? So in any numerical quantity that characterize a given population or some aspect of it. So most common statistic parameter are, when you talk about parameters, you're talking about mean, median, mode, standard deviation. So general assumption, yeah, general assumption when we do a test, a parametric test, yeah, assumption in a parametric test is that populations are normally distributed. That is our assumption, yeah, that they are all normally distributed. Normally distributed. That means they have a normal curve. Normal curve, right? The selected population is a general, they represent the general population. So when you select a sample, a sample, the sample represent the whole population, yeah. So you cannot be biased in your selection of your sample. So that is a general assumption that you make. Then it's a parametric test. Okay, first assumption, normally distributed. Second assumption is that they represent the general population. Okay, and the data is interval or ratio. Then only, yeah, you can do a parametric test. Okay, right. A non-parametric test, when do you do? So you must assumption for non-parametric test. A non-parametric test can be applied when you don't have a normal distribution, no normal distribution, yeah, and no assumption about the population are made, data measured in any scale. Okay, so when you do, you already decided to do a parametric test, and then when you test your normality, we will show you how to test. When you test your normality, it's not normal. So can you jump to a non-parametric test? Yes, you can jump to a non-parametric test. It doesn't matter because you can use any scale. Yeah? All right, testing of normality. Okay. Why I need to know whether my data is normal or not normal? When it's normal only, I can use a parametric test, yeah? So how to check whether your data is normal or not? You check on your histogram. Last lesson, I already told you about all these values, yeah? How do you do using your SPSS? Check on your histogram. So the histogram that you check, you will get you must get the shape. You can look back, yeah, if you don't remember. These are all histogram. So your histogram will follow a pattern of a dumbbell, a bell curve, yeah, a bell curve. All right. And then you must have skewness and ketosis. This one I discussed last lesson. Your skewness must be between positive, negative 1.00. Ketosis, you should be between between plus minus 2. Yeah. So when you get all this data, you said you are already your assumption, you are testing your assumption. So when it's testing your assumption, I told you it's plus minus 1.0. So you must tell her, you must give your citation. Who said this value is considered normality, is normal. Right. And then to test normality, I can also use Kolmogorov Simra KS test. This only you can use this test when the sample size is more than 50. I understand most of your sample you are taking only 30, yeah? 30, that is the minimum, yeah? 30 is the minimum, yeah? Minimum. It's allowed. So if your sample is 30, you cannot use Kolmogorov KS, you cannot use. This is a Russian name, Kolmogorov Simnok. It's a Russian. Right. Then the next one is a Shapiro Wilk. That test you can do if your sample is less than 50. Yeah? So after you do the test, when you get the readout, your significant value is more than 0.05, then you say it's normal. The distribution is normal. So what this slide is telling you, when you want to test your normality, you have to inspect the histogram. You have to see the skewness and ketosis, and then if your sample is less than 50, you do Shapiro Milk test. If your sample is more than 50, you have Kolmogorov Simok test, right? So when the test is run, you got your significant value more than 0.05, then your sample is normal. So when your sample is normal, you can do a parametric test. Okay, here you can see a normal. Yeah, normal. As I showed you just now, histogram. So I can use parametric test. Okay, this one you have a skewness. Skewness means is a normal distribution. Only thing the distribution is more towards left. Yeah, so still can use parametric test. Okay, here severe skew. Therefore, you don't get a curve like that. It's not using the curve. All right. So this one you have to use non-parametric test. Yeah. This one upside, some high, some low, also non-parametric test. So the conclusion here, yeah, a conclusion here, when you have a normal curve, you use a parametric test. All right, normal plus outlier, use non-parametric. You see, outlier. Outlier means extreme values. The value should be between 0 and 15, for example. But you see, there are values 40 and 50. So you have outliers. They are called outliers. So we have to use non-parametric tests. Okay, now you'll be thinking, what is my parametric test? What are the tests that I will use for non-parametric tests? Like t-test. T-test is a parametric test. So t-test only when your population is normal. Then only you can use. Okay. So commonly used non-parametric tests, chi-square, McNemer, the sign test, Wilcoxon sign rank test. All this no need to memorize. When you know your sample is non-normal, you still go to non-parametric test. Then you choose which test you're going to use. Yeah, Mann-Whitney, Krusell-Waltz or H test, ANOVA, Spearman rank coloration test, or Q test, Cochrane Q test. These are common. Of course, we have more than that. Yeah. All right. So chi-square test. Most of the students I see that they like to use chi-square test. Yeah, chi-square because you want to find. Yeah, chi-square test is you want to see any relationship or not. Is there any relationship between two variables? All right. Test of association lah. Is there any relationship like smoking and cancer? Is there any relationship? You want to know, right? So we use chi-square test. Or you want to see any relationship between treatment and outcome of disease. Just like now we are taking vaccine and then we are taking booster. Is there any association with any association or relationship with the number of fatality rate? You see, fatality rate after getting the immune booster, the fatality rate is less. So there is a relationship. Yeah, and we only get cases not until 3 and 4 level. We only get 1 and 2, something like that. Yeah, vaccination and immunity. Okay, and then another one, test of proportions, compare frequency of diabetic and non-diabetic in the weight. Okay, 40 to 50, 50 to 60, 60 to 70, and above 70. So is there any relationship between body weight and diabetic? So we can use a chi-square test. So chi-square test, for goodness of it, determine if actual numbers are similar to the expected theoretical numbers. Okay, like an example here. Attack rates among vaccinated and unvaccinated children against measles. This one, we're talking about measles, yeah? So observed, 10 were attacked, 90 not attacked. Vaccinated, 10 only attacked, non-attacked is 90. Unvaccinated, what you observe, attack is 26, non-attack is 74. So attack 36, non-attack is 164, and total of your sample is 200. Yeah, 200. So from 200, 100 you make it vaccinated, and another 100 non-vaccinated. So you can do a chi-square test. You want to see is there any relationship between vaccinated and unvaccinated children against measles. So that is your problem statement or your objective, your research question. Chi-square test. Okay, so these are the chi-square test. Here is the theory behind the chi-square test, which we are not going to look into it because we have our SPSS program, SPSS program, which will straight away give you the results. I have discussed before. Your calculated value and your expected value is more. It's more than 0.05. That means null hypothesis is rejected and we make a conclusion vaccination is protected. So this is how you make your conclusion, but I'm just showing you an example. How do you do a chi-square test? All right. Besides chi-square test, I can also use Fischer exact test. Okay, Fischer exact test when your sample size is small. Normally, when the sample size is small, the advice is you don't do a parametric test. It's better for you to do a non-parametric test. Yeah. So if you have like a 20, your sample is 20. During this pandemic time, you're having difficulty in getting patients coming to your clinic. But it has to be try to get as much as you can, but if 30 is still acceptable. If you get 5 or 10, then you have to do a qualitative study, which is not popular among PIDC student, qualitative, where you don't do data analysis using SPSS. Yeah. All right. So here the cases is less than 20. Yeah. All right. Besides that, McNamara test is to compare before and after finding in the same individual to compare finding in match analysis for dichotomous variable. Dichotomous variable means yes or no. When your questionnaire says yes or no, do I know the way to decompose my computer when it's no longer in use? So this kind of question, you cannot say, I want to use Likert scale, very satisfied, not satisfied. No, it's either yes or no. You know to discard or you don't know to discard, isn't it? So these are called as dichotomous variable. Yeah, yes or no. All right. Comparing attitude of a medical student towards confidence in statistic analysis before and after the intensive statistic course. So before you took this course and after you take this course, whether you're confident. So the question is, are you confident or you are not confident? So it's called as dichotomous variable. Yeah, we can use McNamara's test. Very straightforward. Yeah. Okay. Other than that, we also have Wilkinson sign rank test. It's a non-parametric test which is always similar to our t-test. To t-test, what you need to have for t-test, you must have two groups. Remember, one group t-test, paired t-test, independent t-test. We have three types. I've discussed that last lesson. All right. So non-parametric test, if you want to do parametric, is t-test. Non-parametric test is Wilcoxon sign rank test. Yeah, this is how he looks like. Yeah, just a picture, just to give contribution. Yeah, acknowledgement to his contribution. Similar to sign test, take into consideration of the magnitude of difference among the pair of values. So sign test, we also call this as sign test, only consider the direction of the difference, but not magnitude. So you can see, yeah, whether there is a change in attitude or no change in attitude. But you don't know, yeah, you cannot make a conclusion which direction, become better or become worse. Here is one example. The 14 different score in BP among hypersensitive patient, hypersensitive patient, BP, yeah, after giving drug A. So you see the values are given. So statistic T is found by calculating the sum of the positive rank and the sum of the negative rank. The smaller the two value is considered, okay, like here. the positive rank is 6, the negative rank is 99. So our sample is only 14. Alpha is 0.05. If T is less than equal or less than T critical, then the Hull hypothesis is rejected. So drug A decrease the blood pressure among hypertension patient. So here we are doing very small samples, so we can use Wilcoxon sign rank test. All right. Besides that, you can also use Mann-Whitney U test. Remember, each test here we have a criteria, yeah? It's similar to Wilcoxon sign test, but the samples are independent. They are not paired. You're not comparing the same group. For example, the easiest one is all of you was sent for one course. All right. So student A before the course, student B after the student A. Yeah, the same student after the course, did they improve or did not improve? So you are comparing the same student. So when the same student, you call it samples are dependent. I cannot use this Mann-Whitney. They must be independent. Okay, two different group, but you're not testing the same thing. They are independent. Yeah, they are not paired. Then only we can use. So the population means are the same for the two groups. You find the average rank with each group. You just find the average. Yeah. All right. You see, for example, 10 dieters following alkene diet versus 10 dieters following Jenny Craig diet. That means they are following two different diets. Yeah, they're not following the same diet. So your hypothesis, you're telling alkene group loses average 34.5 pound, whereas Jenny Craig diet loses average of 18.5 pound. So this is your result. So you want to make a conclusion whether alkene group is better, diet is better, or Craig group diet program is better. So what is the conclusion? You can see that average alkene group, they lost more, correct? Compared to Jenny diet. When individual data is seen, this is the individual data, you see. This one, the participant 1, participant 2, participant 3. So you list down. They are two. They cannot be taking the two diet program. This one is group A, is a different group, different students. This one B, different consumers. Yeah, now you are comparing. Now you look Jenny diet, Atkins diet, Atkins diet. So rank the values. 1 is being least weight loss and 20 is the most weight loss. We rank them. Yeah, we rank them. We arrange them. Which one lost the most, right? Then we add them together and we see, calculated value from the table. The null hypothesis is rejected. So we cannot say Atkins diet is better than Craig diet. So this is how you use lah. All right. Where is it? Okay. Then Krussell values one-way ANOVA. ANOVA is for what? Is for parametric. So non-parametric, we will be using Krussell. It's exactly like what I discussed just now, but here you have same like ANOVA. ANOVA, you will have more than 3 groups. T-test only 2 groups. You want more than 2 groups, then you go to ANOVA. Yeah. And applied on the independent sample with the same shape, but not necessary contribution. We're talking about the distribution. Right. When you want to do correlation, Spearman, rank order correlation. You want to find the relationship between two variables. Yeah, this is a non-parametric, which is equivalent to Pearson. Most of the time we talk about Pearson correlation, but here it is non-parametric. Yeah, non-parametric, we use Spearman. If the relationship is very good, then it's positive one. If it's negative one, is inversely related. One value go up, one value go down. So number of hours of exercising. All right, number of hours exercising, you want to find, is there any relationship in the performance of a student? The more they exercise, they become brighter or they are more attentive. So number of hours goes up, attentiveness goes up. So this is a positive relationship. How strong is the relationship? That is the value. If 0.8 is very strong, 0.9 is very strong. If 0.5 is very weak, in fact, no relationship. Yeah, less than 0.2 is somehow is very weak. There is no relationship. If you say negative 0.8, that means it's inversely. One value goes up, one variable goes up, one variable comes down. There is still a relationship, yeah, although it's negative. So how do you use your SPS to test on your normal, whether it's normal or not? So whenever we do normality test, we always hope to get a normal sample, because when you use normal sample, you can do a parametric test. When the sample is not normal, you cannot do a parametric test. So there will be a question, is parametric test better than non-parametric test? Yes, parametric tests are better, more robust, yeah, than non-parametric tests. But it's still accepted, don't worry. Okay. So you go into SPSS program, go under analysis, go to descriptive statistic, choose explore. When you choose explore, you will have a dialog box there. Yeah. Under the dialog box, you can tick normality. You want to test what? Normality. Right? Then you continue with normality. If you want to test your chi-square test, example here, go under analysis, go descriptive statistic, and you do the cross step, then you can choose. Like you see the test you want to take, chi-square test. Right. Normality, then you'll get a printout. From the printout, you can see whether the sample is normal or not normal. So if you want to find a non-parametric test, I don't want to go through very deep inside there. It's very easy. Just go to SPSS, go under analysis, go to non-parametric test, go under legacy dialog. Then you can have non-parametric test, whether you want chi-square, you want two related sample, whichever you can choose in the dialog box. Same goes for Whitney U-test. Whitney U-test is two independent sample. If it's a Wilcoxon-McNair test, it's two related sample. That one you have to choose correctly, lah. Yeah. Then when two related sample, you choose which one. Yeah. Variable 1 and variable 2. Then under the test type, you can click on Wilcoxon. Yeah, you want McNair or you want sign, which one you want. Okay. Whitney U-test, you can go to non-parametric test, legacy dialog, then you can have two independent tests, two independent samples. You want to see cholesterol concentration and the group. What group? Blood group A, blood group B, or whatever, right? Then you click the dialog box, Whitney. Again, before you do all these tests, you must know what are the criteria that you can do the test. And some students, they will click all, they'll do all the tests, but they don't know how to interpret. It's not how many tests you do. You must be able to choose the correct test. Yeah, that is important. All right, and then for Krussel-Willis test, non-parametric test, it comes under non-parametric. It's an independent sample. Then, for example, it is between drug treatment and pain. Which drug gives you a less pain? Yeah, is there any relationship? So you have to click the Krussel-Willis H test. All right, for relationship Is there a relationship between two variables? Then you can do Spearman. All these tests come under non-parametric. Yeah. Under this, you go under correlated and bivariate because it's a relationship. Is there any relationship between English mark and maths marks? That means if the student is good in English, is the student good in maths? Is there any relationship? All right. So I want to find this. I can use Spearman. Yeah, Spearman. Okay. Advantage of non-parametric tests. Okay. These tests are distribution free. So whether it's normal or non-normal also can use. Yeah. Easier to calculate and less time consuming than parametric tests because the sample is small. So no need to go and hunt for so many samples. So if during the pandemic you only got 30 sample, you want to run a non-parametric test, go ahead, no problem. Yeah? Can be used with any type of data. That is what I like. Okay. Many non-parametric methods make it possible to work with very small sample, particularly helpful in collecting pilot study data or medical researcher working with a rare disease. If you're working with a very rare disease, of course, you cannot get a big sample. Not many people have that disease, rare disease. For example, you have hormone kind of related disease. So if you're searching for that, definitely very difficult to get samples. Or you're dealing with HIV patient coming for your dental treatment. Again, very small. That's why I tell you PIDC during this pandemic, very less patient. So you can consider using a non-parametric method. Yeah. Limitation. Of course, it comes with a limitation, but it shouldn't stop you from doing a non-parametric method. No assumption. Yeah. About the population are usually less effective. You don't know anything about the population, so you never make any assumption. So it's not so strongful lah. The strength is not there. As the sample size get larger, data manipulation required for non-parametric tests become laborious. Yeah, because your sample, your sample become larger, so it is not so powerful, the method. Yeah. A collection of tabulated critical value for a variety of non-parametric tests under situation dealing with various sample size is not readily available. Okay. So this is a summary of a statistic test. All right. So this is a good one. What kind of test can I do? Yeah. Whether it's independent, two sample, dependent, rank and order, measurement. Yeah. What the measurement, categorical, rank or parametric, interval or ratio. Yeah. Oh, this is a summary of what I told you just now. Okay. So that goes the first slide. Okay, the next one, I'm going to talk about developing skill in oral health education. So I'm able to undertake routine clinical preventive procedure, diet counseling, counseling in smoking, able to apply skills learned to improve the oral health of your patient. So the process of imparting information about the health in such a way that the recipient is motivated. So whenever you want to educate the public, actually you want to motivate, motivate to use that information given by you for the protection and advancement of his own, his family, or his community's health. So whatever you are departing knowledge, you are hoping that your information becomes useful to your consumers. Yeah. So under health education or literacy, they represent the cognitive and social skills which determine the motivation and the ability of the individual to gain access to understand and use the information in ways which promote and maintain good health. So that is the definition of health education. So your objective here, whenever you want to um, create awareness among the community, you are actually informing the people. So you are giving them knowledge where it involves cognitive. Yeah. And then at the same thing, you are changing their attitude. You are motivating people, changing attitude, a proper oral hygiene, a proper diet, yeah, a proper exercise program. So all that are actually motivating people, where you call it as improving their effectiveness. So you are dealing with effective part of your skills. And then after that, you are guiding. Okay, you're showing them the correct way for oral hygiene, the correct way to reduce plaque on the teeth, or reduce intake of sugar, right, to take care the teeth. So all that you are guiding into action, not only talking and putting knowledge. Most of us, we have the knowledge, but we are not changing it into action. For example, we talk so much about recycle. Yeah, most of them have knowledge about what is recycle. Yeah, but are they motivated enough to carry out recycle recycling? Yeah. According to a survey, it shows only 5% of Malaysian do recycle compared to Singaporean. Singaporean, they have higher percentage of people involved in recycling. So we cannot say Malaysians are illiterate. They are not illiterate. They are literate. So they have the cognitive objective, but are they motivated enough? Sometimes we are asked to buy recycled plastics, recycled cards, but we are not buying. Why? Because it's too expensive. All right. So it's not motivating. So here we cannot just put in information. How far we can motivate them? Motivation here you can see in terms of action. Yeah, action, the outcome. So how do you achieve this? Regularity, regular. Yeah, you must be regular. You must be persistent. You must have any administrative or service approach, educational approach, a primary healthcare approach. So your level here, you cannot be doing administrative service approach. Yours is more on educational approach. I'm sure PIDC you have program where you go because I met one dental doctor. He was telling that he normally goes around to the schools, yeah, to educate the children about the oral hygiene, yeah, because it starts from young. So that is what you call as educational approach. So models, you also can use models to improve the health education, medical models, motivation models, social intervention models. Yeah, these are all involving like social intervention model. What are the program that you do? Do you do what you campaign? Go around campaigning, yeah, campaigning. You get people to give testimonial, that kind of thing, yeah. Principle, what are the principle that you need to um, have when you do health education, right? Credibility, people believe in your credibility, people believe in the knowledge that you impart. If you are a degree holder in dental, of course you have the credibility. When you go and give speech, people will believe, right? Interest, participation, motivation, comprehension, reinforcement. You just go and talk for 2 hours, then after that you disappear, you don't come back, right? That is not persistent. So that you need to have reinforcement. So like small kids, you need to give them some reinforcement. Okay, when you do this, you follow the guide that I tell you. When you come back in 2 weeks time, I'll give you something, reinforcement. Learning by doing, known to unknown, setting an example. When you go and talk about beautiful set of teeth, a beautiful smile, you must be setting an example. All right. Good human relation. Why should they listen to you? You must have a good relationship, right? Get the feedback. Yeah, get the feedback. So these are showing how you get involved in the program. Yeah. So like you see stages, awareness, don't know anything. Then you give them knowledge. Yeah, they become aware. Are they practicing it? Things to do. Interest. Are they interests? Yeah. And then you do evaluation, how far you have been uh, helpful to their needs. Right? Stages. All right, health communication, a key strategy to inform the public about the health concern and to maintain important health issue in a public agenda. The use of the mass and multimedia and other technology innovation to disseminate useful health information to the public, increase awareness of specific aspect of individual collective health as well as important health in the development. So here you are doing communication. You're communicating with the public with about the health issue. Health here I'm referring to your dental practice. How do you do this now with the use of social media, which is very powerful tool to educate. Multimedia, using technology innovation. This is how the information can reach the public, right? Um, you can also use aids, visual, audio, yeah, or combination audio and visual. Method, how do you can approach individually, you can approach groups, or you can have a mass approach. So you can do health promotion, yeah, improve their health, right? So these are areas of health promotion, yeah. Building healthy public policy. These are more on policy makers lah. Creating supportive environment for health, strengthening community action for health, developing personal skills. You must improve in your interactive skills. Yeah. When you go down to and talk to the kampong people, you cannot use very high level of language. You must see how the politician talk. When they go down to the kampong, they use very bombastic word. Nobody will listen to them. Here you must go down to the level. So here you need to have a personal skills, your own skills, how you reach, yeah, the group. Like say you go and talk with the Orang Asli group. Most of them do not know English. So if you go and talk about oral hygiene among the Orang Asli group, they definitely will not listen to you. So there is no communication skills there. Yeah. Approach to health promotion. So these are educational lah. Ours is more on educational, right? So here the drawbacks lah. Results. The result must be slow. It will be slow. Definitely will be slow. But they are permanent and enduring. Will take longer time lah, right? And sufficient time should be allowed. You cannot be pushing them, yeah. Okay. So these are just ways that you can promote, yeah, promote your oral health among the community, right? Okay. So I think that's all for today's class. But please keep on looking into your Google Classroom. I'll be uploading more articles, yeah, more articles. And if you need any help, you can always contact me, yeah, through my number, yeah. You can PM me individually, no problem, right? So thank you very much. That's all for today.